Okay guys, hopefully this helps a little bit with completing the square, rewriting in Vertex Form, and then also solving in Vertex Form because some of you asked kind of a general question about using completing the square. So our focus here is rewriting using completing the square, and that would be rewriting into Vertex Form from standard form. So let's say we were given an equation that looked something like this, and we wanted to rewrite it in Vertex Form. So first of all, remember what Vertex Form is, which generally looks like this. And so because it looks like this is the reason we're using completing the square, because you'll notice that it does have something that was factored inside of it, but it specifically factored to a perfect square, and that needs to be our focus. So our first focus is to somehow build something that makes a perfect square so we can have this portion, and we can factor things out in front of it or have extra things outside of it that we don't want. So when I look at my equation, I see the 3 as something I immediately know that I don't want in the perfect square, because 3 is not even a perfect square number. So 3 is going to kind of start in my K position, kind of like an outsider of the equation, and I'm going to look to group together the things that have X in them that would be made by this multiplication from this perfect square. So the first thing I have is this thought in my head that I'm kind of looking at this group that contains X's to build my perfect square, and that 3 is not part of that. So the next thing I want to do is actually go ahead and complete the square, which is to find a constant that allows this to factor as a perfect square so it will look like that perfect square in the equation. We found a way to do this, which was to take the b value, divide it by 2, and squared it, but that only works if it didn't have a coefficient in front of x squared that was different than 1. So my next problem is that this says -2. Then my kind of like shortcut or formula for completing the square doesn't work. So I need to factor out that -2. And that's going to be okay because that's just going to become part of this like a value out here that's not part of the perfect square. So I'm going to rewrite this one more time where the -2 has been factored out of this quantity and the 3 is not in that quantity, so I don't have to worry about dividing that by -2. So in this quantity, previously, I had a -2x squared. If I factor out a -2, that would leave x squared. I also had a 9x, and if I factor out a -2, that would be like having 9x and dividing it by -2 to see what's left. Since 2 doesn't go into 9 evenly, I'm just going to leave it as the fraction it would be, and so it would look like this. Okay. The next thing I'd want to do is I want to build this perfect square that's in here. And now I can use the formula that we had because now our lead coefficient on x squared is 1. So I'm going to take -9/2, and I'm going to think about dividing that by 2, which is the same as multiplying it by 1/2, and squaring it, which gives me -9/4 squared, which is 81/16. So that's the amount that I want to fill in this gap right here. So I'm going to write in that spot an additional 81/16. And I just want you guys to be really aware that even though you've added 81/16 into that spot, you've added something that's not worth a value of 81/16. That 81/16 is inside of these parentheses, and everything inside of those parentheses is getting multiplied by a -2. So even though my pencil wrote down 81/16, I have to keep in mind that that positive 81/16 is being multiplied by a -2, and I need to think about what it would be when that's distributed to that. So when that -2 multiplies that 81/16, it will really be -81/8. So even though I've written 81/16, I've added this amount to my equation, and I need to try and even that out. So the way to do that would be to add -81/16 to the other side as well. Sorry, not 81/16. -81/8 to the other side as well, because now I've added the same amount to both sides. And now I'm going to work on rewriting it so it's in this perfect form. And so this comes to a question a couple of you guys had, is like, some of you were asking about completing the square. So hopefully this shows you how to do it. Others of you were asking specifically, like, what do I do after I've got that number? Your purpose every time you complete a square is to make one of these perfect squares, meaning this quadratic factors into two of the exact same factors or something squared. And in this case, in order to make this, to make that beginning term of x squared, we would need an x at the beginning of each factor. To make this ending constant of 81 over 16, we would need a 9 over 4 in each factor. And because the middle terms are negative, we would want these to be minus in here. So right now, this would now look like this. And this is really close to being vertex form. We have our perfect square. We have an a value up here and what appears to be a k value. The only issue we have is that we still have this 81 over 8 on the other side. So I'm going to cancel that out, which basically will bring it to the right side with all the other terms of the equation. And so this will leave me with y equals -2 times my perfect square. And then this constant here will actually be whatever I get when I combine 3 with 81 over 8. So I'm going to think about what that is over here. I'm going to make common denominators to add them together. And so then that becomes 105 over 8. And so that would complete my equation in vertex form. So this is rewriting in vertex form. Okay, so think about splitting up the equation into different pieces, then factoring out your a value so you can complete the square, and then how to rewrite it and make sure that that amount shows up on the other side of the equation as well to even it out. And so this is what you would get in vertex form. So hopefully that's helpful with how you'd use the completing the square, what you would do after completing the square, and how to walk through the vertex form. I'm going to send this video to you guys. Then if you get it and you have specific questions, send it back. I'll send you another one later tonight. Okay, thanks.